So you see, we're not getting very far in biology without all that physics and chemistry. Okay, we've got one ion here that's part of this pH thing. The other one is the hydroxide ion. So the name is hydroxide ion, and it looks like this. There's an oxygen atom with a hydrogen atom, and this molecule has a negative charge. That's why it's not ion. What do you get if you put the hydrogen ion together with the OH ion? If you put these two ions together, you're going to get water. And in fact, that's where they come from. These ions are coming from water, in any source of water. The water is actually coming apart and going back together randomly and continually in that water. So when you're drinking your water in your purified Aquafina water bottle, some of those water molecules aren't actually water molecules. Some of them are hydrogen ions and hydroxide ions. Make up a case study. Do you see these ions? In fact, if you have a really pure sample of water, which is actually very difficult to come by, but if you did happen to have a very pure sample of water, the number of hydrogen ions would equal the number of hydroxide ions. I'm going to erase this part, is that okay? Another way that we note this is in brackets. When you put an atom or a molecule in brackets like this, or you write out the name of it, what you're demonstrating is the concentration of. So in other words, the concentration of hydrogen ions equals the concentration of hydroxide ions. There's another, if those of you new, brand new to chemistry, another notation going on up here that you might not be familiar with. This first thing that I wrote up here is an example of a chemical reaction. The chemical reaction is just the breaking or reforming of chemical bonds. And so what's happened up here, the way I drew this out, hydrogen ions meet up with hydroxide ions and they form a covalent bond together, and that forms water. And the arrows, notice the arrows are going in both directions. This is a chemical reaction that can go in both directions.
Is that what makes it a covalent bond? Just if we go in both directions?
No, it's just that they're going to actually bond together to share electrons. The ionic bond, if you're comparing it to the ionic bond, it'll look the same kind of thing. And really, an ionic bond you can consider as just an extreme type of polar covalent. So they're still sharing or having electrons interact. Okay, now for the actual pH bit. Now the pH scale is really a logarithmic scale. And I'm not going to go into calculating logs, but it can be used to actually give a real concentration, actual number of atoms that are involved here. But what I want you to actually be able to do with this pH scale is be able to tell how many hydrogen ions there are in comparison to the number of hydroxide ions. So again, the pH is looking at the proportion of hydrogen ions to hydroxide ions. In